Fearless Leader here. I wanted to talk a little bit about this problem because I noticed that the greatest median time spent on any problem from this week's set was on problem 7, so I thought it'd be worth saying a few things about it. So before you continue the video, I want you to pause and think about how you're going to solve this problem. Or if you don't know, I want you to think about where you got stuck. Okay, so I don't know, it's hard to know where you got stuck without talking to you, but I know one thing that can be kind of overwhelming for this type of problem is that there's so much going on. You have 8 tracks on the player, you like 2 of the songs, each of the 8, oh my god, oh my god, oh my god. So think about techniques here. This is going to be a great problem for solving with a tree diagram, and the cue for that to help you see that is that we've got 8 tracks and we're going to choose 2 of them. So this is a multi-stage experiment, and those are great candidates for tree diagrams. Oh, not P, experiment. So again, I like to start my tree diagrams with go. This is where I'm starting. And the first stage is a song gets played. And I either like the song or I don't. And those are complementary events because if you choose to say that I like this song, we're saying the complement is you don't like it. And I know that you could say you kind of like it or sort of like it, but we're not going there. So now we have to think about what is the probability that the first song played is that we like. And this is a classical probability because we have 8 tracks to choose from, 2 of which have the desired property that we like the song. So we have 2 of the songs that we like, 8 songs total. That means there are 6 songs that we don't like. So the probability that the first song played is one we like is 2 on 8, or 1/4. I'm going to leave it as 2/8 for now just because I feel like it. The second stage, we're going to have the same possibilities as we did the first stage. We either like the song or we don't like the song. And if the first song was one we disliked, then the second song could either be like or like complement, dislike. Now, before you go on, I want you to think about, pause the video, think about what the probabilities are for each of these little paths. Okay, so this is a sampling without replacement. So, and how do I know that? Because good problem solvers read the problem many times. And so I look at part D, redo questions A through C if a song can be replayed. So that means this first go through, we're going to do this without replacement, meaning that there's only 1 song left that we like, 7 songs left total. So we're assuming in this situation that the music player is not going to repeat tracks. Then, of course, this must be 6/7. And here, there are still 6 songs we like, because we haven't played any of them yet, but only 7 songs total. And then, of course, there's 1 song that we... Oh, excuse me. No, hold on. I don't think that's right. Let me just walk this back for a moment. And remember, this is part of being a good problem solver. There's this idea in math that the kids who are good at it are the ones who get the right answer right away. Utter hogwash. Good people who are good at math think long, deep, and hard. So there are 6 songs we dislike. So there are 2 songs here that we like, 7 to choose from. And that means there are 5 that we dislike because we already played one that we disliked here, and 7 here. Okay, that makes more sense. And see, look, I'm not going to record this video over again because I think it's valuable for you to see that everyone makes mistakes. And the way you get past that in math is that you keep making mistakes and you keep asking yourself over and over and over again, does it make sense? Just like as a mountain biker, when I'm riding the trail, I always have to be thinking, what's next? What's next? I can't have my nose down at my front wheel. I got to be looking ahead to see what's coming up next. So you're always asking yourself, does this make sense? And if it doesn't make sense, ask me about it. Okay, so back at the ranch. What is the probability that among the first 2 songs played, we like both of them? Only 1 branch where that happens, and that is this branch. So probability that we like both is these are independent events, so we multiply probabilities. And now I'm gonna write this in simplest form at this point. So I know that this is 1 on 28, which my handy dandy computation device will tell me is 0.036 to the nearest thousandth. 0.036. Oh, sorry. 0.036. Oh, yeah, well done. Would it be unusual for you to like both the songs? The convention our text uses is that an unusual event happens less than 5 times out of 100, or 5%. So since this is less than 5%, we'll say yes. That's very arbitrary, but that's the convention our book uses. Now, the probability you like neither song is actually this going to be this. Oh, wait, I want a different color. How about, no, not yellow, gray. This is the only branch where we have 2 songs we dislike. Probability, like, complement both. 6/8 times 5/7. 3/4 times 5/7. And I think it's easier to multiply these fractions first. And so I'm gonna, now I can just type that into the calculator. 15 divided by 28, 0.536, and that's to the nearest thousandth. 0.536. Yay. The probability you like exactly one song? Stop the video for a moment, see if you can find it. Well, I'm wondering if you thought that that would be these middle 2 branches, and it absolutely will be. So I'm going to, oh geez, what am I going to do? I'm going to try to find more space on this paper, and it's not going well. Sure. So probability like exactly 1, that's terrible notation, don't tell anyone, is this branch. So we have 2/8 times 6/7 plus 6/8 times 2/7. Now I know what you're thinking. Whoa, 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 Dr. Fisher, what is this adding crap? You said that we're supposed to multiply. So notice that these events are independent, but these not so much. These are different branches. We don't multiply the results of different branches. We multiply along paths, but then if we choose a different path, that is an addition component. So 2/8 times 1/7 is the probability that you like both songs, but the probability that you like exactly one is 2/8 times 6/7 plus the result from this other branch. And you might have noticed that these are the exact same number twice. So it's 1/4 times 6/7 added to itself, so we can multiply by 2, and that is of course 1/2 of 6/7, which is should be 3/7. So let's go put in 3/7, 0.429. Okay, there it is. So now, notice you have to read the instructions carefully. Part D, you're like, what do you mean? I already did this. No, you didn't, because now your job is to redo parts A through C if a song can be replayed before all songs are played. So you'll have to redraw the tree diagram and recompute the probabilities. So I'm going to let you do that using this video as a reference, and remember that if you're allowed to replay the songs, that's going to change what happens in the tree diagram. And I'm going to let you think about what that is, but please let me know if you have further questions, and I hope this was helpful.